The calculator automatically forms the element stiffness matrices based on the information that you enter about the geometry and properties of the trusses. When you apply boundary conditions and loads, the calculator uses this information to form the global load vector and nodal displacement vector. Finally, the global stiffness matrix is formed and the global problem equation is solved to find the unknowns in the nodal displacement vector. This gives the displacement at each joint in the truss structure. From this data, element strains and stresses are calculated and displayed in the results section. This tutorial gives you an idea about how to solve 2D truss problems by creating a text file and then uploading the created text file in the website. After opening the website, click to solve the problem by uploading file. Let's suppose we have this 2D truss problem and we would like to solve it using the website. This problem consists of 5 nodes, 6 elements, 2 constraints and 1 force. The first step of solving this problem is to download template file. This text file will guide you to create your own text file. If you are not sure how to fill the downloaded text file, there are 4 examples that you can use them to make your text file similar to them in the format. Don't remove any information from the template file and follow the instructions of this tutorial carefully to make your file successfully. Click to download template file and then open it. Now, we will fill the downloaded text file with the data of the problem. As we discussed before, our problem consists of 5 nodes, 6 elements, 2 constraints and 1 force. So we will write 5 beside the number of nodes. The number of elements are 6. The number of constraints are 2. And finally, we have only 1 force. The next step of solving this problem is to add the coordinates of the 5 nodes. Basically, the coordinates of node 1 is 0, 0. The coordinates of node 2 is 3, 0. For more nodes, copy the coordinates of node 2 and then paste it. Change the number of coordinates from 2 to 3 and then fill it with the data of node 3, which are 0 for x3 and 3 for y3. Repeat this process for the remaining nodes. The coordinates of node 4 is 3, 3, and finally, the coordinates of node 5 is 6, 3. The third step of solving the problem is to connect the nodes with elements and specifying the cross-sectional area and elastic modulus of each element. For example, the first element starts at node 1 and ends at node 2. The cross-sectional area of the 6 elements is 8 meters squared and the elastic modulus is 1.9 megapascal. We will repeat this process for the remaining elements. The fourth step of solving the problem is to add the 2 constraints which are at node 1 and 3. The both constraints are in x and y direction. The last step is to add the forces. We have 1 force only at node 4 in the positive direction of y-axis. It has a value of 500 Newton. When you finish, save the text file and then go back to the website to upload your text file. In order to upload the text file in the website, you can drag and drop the text file in the drop file area or click to choose file button and then select the file. When the file uploaded successfully in the website, the content of the file with solve button should appear. Click solve button to show the answer. The answer includes the nodal deflection, the stress of each element, the strain of each element and reaction forces. The aim of the amplification constant is to make the final graph clearer and to see how the nodes will be deflected. To follow the step-by-step solution, click the step-by-step button at the end of the page. New page will be opened automatically with the complete solution. The step-by-step solution shows the complete answer starting from the length of each element to the reaction forces. If you have difficulties to read the matrices of step-by-step solution, let's take the stiffness matrix of element 1. This matrix has 4 rows and 4 columns as shown. To make it clearer, let's make each row in a new line and replacing the commas by a large space with removing all the square bracket. Now, I think the matrix is clear and understandable. If you are happy with the step-by-step solution and you would like to keep it on your computer or even send it to your email, there are 2 buttons were added specially for these purposes, which are Save the results as text file and Send solution to email. The large red button give you the ability to clear the database very quickly and start over to solve another question.